Okay, guys, so we're going to learn about the real number system. Um, Basically, all this is a visual way for us to describe the different types of numbers that we use every day. So all the numbers we use um, each fit into a category. So we're going to learn about those categories. We're going to start with the definitions, and then I give you a visual at the bottom that I want you guys to copy down into your journal. Now, the best way to do this, in my opinion, would be to pause the video and then write down what I have and then restart it as soon as you're done writing and then get each part. Now, I'm going to ask you a few questions within the video to make sure you're actually watching the video. And then when you're done, you're going to take a little mini quiz on Classroom to make sure you watch the video. So let's start. The first type of number is a natural number. Okay, it's also called a counting number. I put AKA, which means also known as a counting number. So these are the numbers you started with when you first learned how to count. And so if I was to count the number of students in my classroom, I would probably start with the number one. I would say 1, 2, 3, 4, 5, and go on and on until I counted all of the students in my class. So we call those natural numbers, but we also call them counting numbers. And so counting numbers are always positive. If you're counting something, it's a positive thing. And it always starts with the number one. So natural numbers always start with the number one. Okay, it goes from one all the way until infinity. And so you have that there. That is positive infinity. Negative infinity will have a negative sign in front of it. So this is from one all the way until positive infinity. And those are your natural numbers. The next set of numbers adds in the number zero. So we have all of the natural numbers, okay? The whole numbers include all of the natural numbers along with the number zero. Okay, so again, natural numbers, you start at one, you count 1, 2, 3, 4, 5, all the way to positive infinity. With the whole numbers, you include all of those natural numbers, but you add the number zero, because what happens if I had 0 students in my class? I had to be able to describe that. So we have the number 0. So again, whole numbers include all of the natural numbers, but it adds the number 0. So it starts at 0 and goes all the way until positive infinity. That means it goes on forever so long as they're positive whole numbers. Okay. The next set of numbers, they include all of the whole numbers. Okay, and remember, the whole numbers included the natural numbers as well. So we start with natural numbers, 1, 2, 3, all the way to positive infinity. And then we have the whole numbers, which starts at 0, all the way to positive infinity. So integers includes all of those numbers and their inverse. Okay, inverse means they're opposites. And so what do I mean by opposites? So if I have this set of numbers here, okay, we have 0, 1, 2, 3, all the way to positive infinity. So I have to ask myself, what is the opposite of 1? Well, the opposite of 1 is negative 1. The opposite of 2 is negative 2. The opposite of 3 is negative 3. So it includes all of these whole numbers and their opposites. Okay, and so the opposites go all the way until negative infinity. So the integers are from 0 to positive infinity, but it is also from 0 to negative infinity. Those are integers. So anytime you see negative numbers, if it's a negative number, if it's a negative whole number, meaning it's 0, 1, 2, 3, but they're negatives, negative 1, negative 2, negative 3, or a number like negative 33, or a number like negative 100, or negative 1,200. Either way, if you see those types of numbers, those are integers. If you see those negative numbers, those are integers. Okay, and so next we have rational numbers. Okay, so rational numbers includes all numbers, natural, whole, and integers. It includes all those numbers that can be made into a fraction. So we have to think, can I make the number 1 into a fraction? Yeah, I can just put it over 1. I can make 2 into a fraction, 2 over 1. Or if you look at the negative numbers, I can make negative 2 over 1. That's still a fraction, right? So any number that can be made into a fraction is a rational number. And so some of the other numbers we look at when it comes to rational numbers are decimals and fractions and percentages. Can I make a decimal into a fraction? Absolutely. Okay, can I make a percent into a fraction? Absolutely. Okay, percent means out of 100. If I want to make 56% a fraction, I would just put it over 100. Okay, this number here, we would say it's 1/10. If I want to make that a fraction, I put 1 over 10. Okay, so any number that can be made into a fraction is a rational number. Okay, but this is important. That fraction must terminate. And by terminate, I mean end. So for example, we have 0.25. Well, the number stops at the 5, so it terminates, it ends. 0.25, that's it, right? So that's a terminating decimal. So it must terminate or it must repeat. So it can terminate or it can repeat. So an example of a repeating decimal is if you had 0.33333, it never stops repeating 3, we put a line over it so that we know that it's a repeating decimal. If it repeats or if it terminates, it's a rational number. That fraction must repeat or it must terminate. Okay, it has to be one of those things. Either it repeats or it terminates. That has to happen. Okay, so some examples, like I said, here we have the number 1. That's a rational number because it's a natural number. We have 0. That's a rational number because it's a whole number. We have negative 36. Well, that's a rational number because it's an integer. It's a negative. Okay. We have 1/10. Well, that's a rational number because I can make 1/10 into a fraction by putting it over 10 since it's 1/10. We have negative 1/3. That's a fraction. Even though it's negative, it's still a fraction. And that's a rational number. We have 56%. It's a percentage, but I can still make that a fraction by putting it over 100 because percent means out of 100, so that is a rational number. Okay, so down here we have a little diagram. Okay, and so I want you guys to draw this diagram in your journal, and you're going to start here in the middle. And really, I should have drawn this with you, but since it's already done, we'll go ahead and use it this way. And again, we'll do this in class as well, so you'll have a lot of practice. The first thing is we look at natural numbers. Right here in the center, those are natural numbers. It's the first circle you draw. The one in the middle, it's a natural number. So an example of a natural number is number 1, number 2, you can have the number 6. Those are all natural numbers. Okay, so next we have whole numbers. And so the only number that's different in regards to natural versus whole, the only number that's different is the number 0. Okay, and so to remember this, we have the word whole, W-H-O-L-E. The O should remind you of a 0. Okay, that is, I know that looks bad, but if I rewrite it, W-H-O-L-E, let that O remind you of the 0 in whole numbers. Okay, so next we have integers. The only numbers that are different in regards to integers are the negative numbers. So like negative 3 or negative 6 or negative 9 or negative 49. As long as it's a negative whole number, we call those integers. And so I underline the IN in integers, and the reason why I did that is because it's whole numbers or their inverse, which means opposite. So you can use that to remember IN here, integers, inverse. Those are negative numbers. And then last but not least, at the bottom, we have rational numbers, and that's your last circle. Rational numbers are any number or any numbers that can be made into a fraction. So, and again, this fraction must repeat or it must terminate. If they don't repeat or they don't terminate, it's not a rational number. But it includes all of the natural numbers, all of the whole numbers, and all of the integers, okay? But it also adds on the numbers we don't have in here, like 0.3 or 0.33 or 1/3 or let's say 2/9 or let's say 13%. These are all rational numbers. So it includes all of the decimals, percents, and fractions, um, as well as the integers, as well as the whole numbers, as well as the natural numbers. All of these numbers are rational numbers. Okay, and so I underline the ratio part of rational because a ratio is a fraction. A ratio is a fraction. And so whenever we see rational, the root word in rational is ratio, which means fraction, A over B. And that's important. So again, uh, the key phrase in rational is ratio, which means fraction, any number that can be made into a fraction. We have integers. You underline the in for inverse because integers are whole numbers and they're inverse, which means negative. And then we have whole numbers. Go ahead and underline the O in whole because that reminds us of a zero. Because whole numbers include all the natural numbers and zero. And then natural numbers are just our counting numbers 1, 2, 3, 4, 5, so on, all the way until positive infinity.